Okay, so this is a short review session. Maybe you're watching this the night before of your paper 3, or maybe you're watching this live. Okay, so in this video, I'm going to show some questions, paper 3, that I have seen students do in the Winter 20 series, and also talk about common mistakes, right? So the first request I have is to talk about decimal point and significant figures. Okay, so when it comes to decimal point and significant figures, it depends on the purpose of these things. All right, so significant figures and decimal point, they represent different things. So for example, in decimal point, right, if you want to count the number of decimal point, you know how to count, right? It's the placing of the number. So sometimes, for example, you can talk about ones, tens, hundreds, thousands, all right? So when it comes to this decimal point, I think it's pretty straightforward. But when it comes to SF, we only count the trailing zeros, like 8.00 is 3SF. The leading zeros, we don't count. Okay, if you are generally struggling with SF, imagine you write all of this in standard form. And when you write all of this in standard form, you will know how many SF there are. Like for example, this one is 5. So always go to the pocket. If let's say you forget already, okay, go back here and see. Okay. Now when it comes to measuring something, let's say you take up a vernier caliper and you measure the diameter of a wire, or you measure the diameter of, let's say, a tube or a plastic tube, or the length of a rod, then please make sure that the precision is related to the decimal point. So always check the instrument in your lab. So what are the instruments that you could get? You could get a ruler. So the precision is 1 mm for a ruler. Okay, so a general ruler, okay, let me just open up. If you don't remember, all this is also in your OneNote lah, okay? I have copied this in your OneNote. So if let's say, I don't think I need to show you a picture of a ruler, right? Okay, so, and all these are also recorded. So if let's say you want to find how to measure certain things, they're all inside this. If you cannot find this in your AS Lab P3 skills, just ping your teachers or ping me lah. Okay, I will tell you where to find it. All right, so vernier calipers and micrometer, you can see this one is in increasing decimal point. All right, so read your instruments. Protractor got no decimal point. So when it comes to decimal point, it is corresponding to the smallest reading. Let me write that down for you. So the first order of business is to talk about decimal points. Zoom in. When it comes to decimal points, follow instrument. N is for measured quantity only, measured physical quantity. If you measure it, if you read a scale, whether it's a protractor or a vernier caliper, there's a scale for you to look at, like that. Then this one is decimal point. Okay, so any kind of measurement, we look at decimal point. There's no SF here. No one cares about SF. Okay, so for measured quantity, it's decimal point. Okay, second one is significant figure. Significant figure is to follow the original substituted value. Okay, and this one would be a calculated quantity. If you take out your calculator and you press, you square, you divide by 10, you, I don't know, power 3/2, any kind of calculated quantity, we follow the original substituted value. Okay, so if you go back to this pocket guide, you will see that here are some examples, calculated values. So you follow the same, okay, or the least number of SF. Okay, so for example, if you have your X is 1.25 and your Y is 0.8, okay, so this is 1 SF, so your answer is 1 or 2 SF. Follow the least SF, the least precise of the measurement determines the SF. It's like you do group work, you are only as strong as your weakest link. So you are only as precise as your least precise reading. So if you look at this one, This one will write 0.98 because this is 2 SF. So this is 2 or 3 SF. Okay, so I'll put this here as well. So this convention is the general standard that we apply because we have to honor the SF that is provided that you are able to measure lah. So for example, if you look at this, follow the least SF. So which one is least? I will highlight the least SF. This one is least SF. This one is least SF. These two are the same. So you can follow this, you can follow this, it doesn't matter. So 1 SF, when you come here, is 1 or 2 SF. This is 2 SF. This is 2 or 3 SF. 3 SF, 3 SF, they are the same. So 3 or 4 SF. If let's say now your X and Y is 1.25 and 0.7858, then we will follow this one already. This is least SF. So then your answer is still 0.983 or 0.9835 because this 0.125 is 3 SF, least SF, so this one is 3 or 4 SF. Okay? Does that make sense? So follow the SF. We do not check decimal point at all when it's calculation. So for example, when it's 20 degree, this is 2 SF. Can? 2 SF. So this is 2 to 3 SF. 2 SF, you square root 2 or 3 SF. Can or not? This is 2 SF. Are you going to power something? 2.5. So you either write 6.3 times 10 power negative 5, 2 SF, or 6.27 times 10 power negative 5, 3 SF. Okay, so follow the least SF or least SF plus 1. Okay, when repeated reading, you can add 1 SF. Basically, when you are calculating, you can increase 1 SF. But there's no point for paper 3 to have too many SF that you cannot plot, and now you are forced to spend a lot of time rounding the value when you plot your graph. There is legit no point in doing that. Okay, so that is the whole decimal point convention. Okay, and from the chat, there's a comment to ask me to address this. Okay, so I will mark this and comment on this. So here, you can see you measure SX, you measure SY. These two are measured quantity. You take the ruler and measure. Okay, so in this experiment, there was a tube. Okay, it's also recorded, this experiment. The tube, the ball fall down. Okay, and then you measure, I am assuming this is SY, I don't know lah. Let's say this is SX. I don't know the experiment. Okay, so if you measure this one, although it's a bit weird, doesn't matter lah. You're measuring something lah. I don't know the experiment. Okay, so let's say you measure SX, all of this is measured quantity. I look at DP. DP. Everything here nearest mm. That's why this one is wrong. Okay, so now I check row by row. Look at SF. This one is calculated. Calculated means we follow least SF. So let me highlight the least SF. These two SF is the same. Least SF, least SF, least SF. SF is the same, SF is the same. So this least SF is 2. 2, 2, 2, 3, 3. SF, you don't have to write, you just do this in your head. So now this calculated SF, this one can be 2, 2, 2, 2, 3, 3, or 3, 3, 3, 3, 4, 4. So if I look at this, this is 3. This one is 4, wrong. Okay, so this is 2 or 3, 2 or 3, 2 or 3, 2 or 3. Here is 3 or 4, 3 or 4, 3 or 4. I do not care about DP. For calculated values, DP does not matter. Am I answering your question here, chat? For measured value, we only look at DP. Okay, so like that lah. So generally, when we mark a table, okay, we go through the same process of, are there 6 readings? So 6 readings, normally you will get 4 to 5 marks already one. So please don't leave it empty lor. Okay, then we will check the heading. You can go through this process when you look at your table. Okay, did I label all the things they asked me to label? SX, SY, SX square. Okay, So you may need to actually calculate, measure some other stuff I don't know, or do some calculation. It's okay to have more than these three things if you need it, okay? So look at the heading, it must have a convention like this and a unit. So something like SX over cm or meter. Then we will check the decimal point, 1 mark. For decimal point, we will check the measured value, measured dp, okay? Then we will check the significant figure, 1 mark. So this one is 1 mark. Then we will check calculation of xx squared, not always, but sometimes. Heading dp sf, and then there's this thing called range, 1 mark. So total is 10 marks. If this is 4, then the total is 9 marks. Everything is different, okay? So generally, right, I think for you, when you increase the SF, then everybody increase. If you do 333, then it should be 44. If you do 222, then it should be 33. Be consistent. Okay, because when I'm marking, right, if I see, okay, this student write 25, this is 3 SF, so I expect this one to be 3, 3, 3, and then I expect this one to be 4, 4. So I do not recommend you follow 3 all the way because you are not being fair to your calculated value. So when it comes to experiment, it's about consistent treatment of all the data. If you increase the SF of everything, then everything should increase. So it's either you do, all 3 and then 4, 4, or you do all 2 and then 3, 3. Is that clear? All right. So either you do all 2, then 3, or all 3, then 4. Okay or not, chat? So you'll be consistent lah. It's not fair, right? If let's say everybody, it's like every student, I add 1 mark, but then when I reach these 2 students, no need lah, you no need to add marks. Not fair lah. Okay, so you either do all 2 then 3 or all 3 then 4. All right, so this is regarding table, and you normally find this in question 1. So how did the ON20 paper look like, and what are the oopsies that some of us did? Okay, there's so many things. I'm gonna start closing stuff. Give me a sec. Close, 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 close. No, 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 no. Okay, so the first variant that our college got last year was a circuit variant. So sometimes when you open question 1, right, you may see something that you take your time, no rush, okay? So you can see this is very nice. They actually show you the different ways you can connect the resistor so that you have different values of R. Okay, no? And then they say that you can set up a very simple circuit like this, where between F and G, you can put any one of these resistor. You know how this question is helping you? There's no problem with range. Your smallest possible reading is 22.7. Your largest possible reading is 204. So you should have all of these in your table. Okay, and then you just connect this very simple circuit, and then you just repeat. So the only problem that I've seen students do is they either skip certain reading, especially the resistor one, or they didn't connect the battery properly and use all the battery that is given in the table. So I think for this particular experiment, they are given 3 batteries, but the students have problem connecting with the right cell holder. Okay, so let's look at a general battery. Ding, ding, ding. Okay, where is it? There we go. So normally, right, when it comes to experiment, we will give you either some circuit, some forces and kinematics, and some oscillation. Okay, so if let's say there's circuit, you should pay attention to the multimeter and the cell holders to check. Okay, and then you have all these other things that you need to look at. And then for kinematics and forces, how to use retort stand, Newton meter, protractor, what to do with magnets, oscillation, how to record timing, and dealing with unwanted planes of rotation. Okay, so let's look at this one first. You see here, this is your, I don't know which one you will get. You may get something different. It could be a green one. Okay, So in this case, right, please pay attention to the instruction that your center will give you. So your center will tell you, please place the voltmeter at a certain reading or at a certain reading. Okay. So if you want to know how a voltmeter works, okay, everything here is that's it. You can see that this is DC voltage, this is DC current, this is resistor, this is AC current. Okay. You see a straight line like this one means DC. You see a wavy line, this is AC. Okay, and resistor is this one. On the stream and YouTube channel, we have a playlist with all the paper 3 stuff. So for those people who are watching on stream, you can find it, just go back to the post lah. But if let's say you are watching this from, okay, let me go find my playlist. Ding, ding, ding. The experiment one, you can find it by searching through our playlist here, lab equipment tutorials. Okay, so we'll talk about how to use micrometer, how to use multimeter, how to magnetize a nail, etc., etc. There's some stuff here that if you need it lah. Okay, so everything is already in the playlist. Reach out if you need to know where the playlist is. Let's talk about cell holder. You may be given a cell holder that you have never seen before. These are a cell holder that you've probably seen before in your lab. So how to connect? My suggestion is you just connect directly to a multimeter lah. You connect a multimeter like this, and you see, oh, this is 1.5 volt. That means this one is 1 battery. If you connect here and here, then it's 2 battery. It should be around 3 volt. This one they label for you very nice, so no problem. And then this one you don't know leh. So actually when you connect like this, this is parallel. You connect like this is series. Look at the connecting plates. This one is connected to here, so this battery is side to side. When the current pass through the battery, it will pass through like this. But if you connect like this, it's parallel. When the current come in, it will split into two. Some will go to this battery, some will go to this battery. So whether it's series or parallel, if you either you already know because you thought about this, current come here, some can go here, some can go here. So this two is parallel. And then current that pass through here will then recombine and come back here. So this one is series. If you don't know, feel free to use our big boy meter to measure lah. You measure here to here, you just measure only. If you don't know, you can ask. Okay, a few problems. Always check your wire for 0 ohm. Okay, so if your wire is faulty, hopefully it's not because we will be giving you new, fresh wire. Okay, actually, good center should do that for you lah. So try to make sure that the wire is 0 ohm and the meter is working. Check everything in your circuit if you have a circuit. Okay, make sure the connection is tight. Read the reading fast. And if let's say after 20 minutes, you still GG your circuit, please ask for help. Okay. It's only 2 marks out of 20. So you can give the invigilator the 2 marks, but you can conduct the experiment. Second thing about this one is the way you clamp this, you also must make sure that it is in contact with the wire. So the connection really matters. If circuit come out, I don't know if circuit will come out, okay? I'm just saying. All right, so that would be for circuits. And generally, when I look at the students, they were okay. The only problem is the cell holder lah. After that, it's just pretty standard. You draw your graph. Okay, for the last and final time, whenever, so the table you understand already. Whenever we look at graph, right, you want to find gradient. I hope you know the best practices of looking for gradient and also drawing your line of best fit and also plotting your graph. Okay, so I could probably roast another graph paper, but I think I will just show you the things that you should pay attention to lah. Okay, so let's say you look at this. Okay, every year the mark scheme is the same. We look for the same things, meaning we need sensible scales. We need the plotted area to be more than half. And we also need the scales to be labeled, and then the marking should not be 3 cm apart. Okay, no more than 3 cm apart. So when it comes to graph, right, let's say you move on to plotting your graph in your question 1 mark is about axis and scale. So the first thing I check is, did you label? Is there unit? Did you plot the right graph? Okay. Second thing I check is the scale. Plot area. Is it big enough? Must be more than half the paper. Okay. So this means if let's say this is your graph. Okay. I need your 6 points because minimum you will have 6 points. What I will do is I will roughly take this area and you have to make sure it's more than half. So this is your plotted area. If let's say you decide for whatever reason it is to start plotting here and then your 6 point finish already, but you're like, yeah, Miss Lee say must half, never mind. I draw my best fit line long, jokes on you. I will still only take this as your plotted area. Less than half. Okay. Second thing I look for is, did you mark the scale? And is the scale proper? Okay. So a reasonable or a proper scale only have a few variety only. You either go 1, 2, 3, ... So 1, 2, 3 include 0.1, 0.2, 0.3, 10, 20, 30, 100, 200, 300. Okay. You could also go 2, 4, 6, 8, ... Sometimes you could go 5, 10, 15, ... That's it. This is the preferred gold standard. Choose a scale that you can fit. A silver standard scale sometimes can, preferably if you don't do it, is you follow a scale of 4, 8, 12. Not preferable, but it's still okay. Anything else besides this cannot already, okay? Right? So when you label, you should label every 2 cm. Every 2 cm, you draw a marking. Okay? You do not need to start from 0 so that your plotted area is big. Origin, not needed. Okay? So when you don't start for origin, okay, let's look at our notes. If we don't start for origin, right, then how do you draw that? So if you go to your lab skill folder, there is a guide on how to draw a graph here. Okay, this one cannot. I don't care, cannot. You draw a graph this way. There's no zigzag pattern because if you do a zigzag pattern, I don't know what to do with these 2 cm boxes here. What do I do? Do I ignore them? Do I assume that they're not there? That's very sad. So I still want to be able to read values like 65 or 63. So I need to start from 60. Okay, no spring, no dotted line, no funny business. You just draw a line down, you start from 60. You don't have to start from 0 as long as your graph is big. Okay, so here there are a lot of notes that you can do and also how to draw best fit lines lah. We want this one where the points are balanced. When you find gradient and y-intercept, the bigger, the better. So we look at the triangle. So this axis, all of this is just 1 mark. Second mark is plot. Did you plot your graph properly? Is all the points plotted? You have 6 correct point. 1 wrong point, I minus 1 mark of 0 already. And then the size of the plot. Okay, so if you need a recap, okay, the size of the plot all must be small. Must not be more than half a small square. Okay, so if you think about your graph paper, as I steal a graph paper from this question. Okay, let's take the. So let me take a thing. So all the correct one will be in blue. This is okay. This is okay. Okay. This is okay. This is also okay. The not correct one is red. This is not okay. This is not okay. This is not okay. And this is not okay. Too big now. All right, so this is good. This one is wrong. Okay, 6 correct points, size of the plot. Next is quality. You generally don't know what the quality range is. Okay, so my suggestion is, if can, is plus minus 1 cm from the best fit line. But if you don't have, it's okay to just give them this mark. Okay, so next we talk about the best fit line. If you want your best fit line to be correct, it should be balanced. But also at the same time, if let's say you have an anomalous point, maybe don't know why you got this point here lah, and you want to draw a best fit line like that, and then you want to tell the examiner, please ignore my weird anomalous point here, please circle and label anomalous point. Okay, so make sure if there is anomalous point, it is labeled and circled. Okay, then you are going to build your triangle to find your gradient. The bigger, the better. Draw a big one. Please do not try to avoid using plotted values. Use the point on the line. Try to only use points on the line, not the plots that you plot. Okay, so draw a triangle. 1 mark for gradient. When it comes to gradient, I need the triangle to be big. More than the hypotenuse must be more than half the line. Okay, so is it big? Okay, did you read the coordinate correctly? Here is x2, y2. Here is x1, y1. You can help the examiner like you a bit better if you write down the coordinates. Not that you write down, they don't check, but they will like you a bit more if you write down lah. Okay, so this one is gradient, no. I must see this format and then must have correct calculation. Any one of this is missing, you will lose your mark. The other mark is y-intercept. Means no need unit, no need. You want to, you can write lah. But I generally suggest that you start writing units here, because normally in the last part, they will ask unit from you. So if you already know the unit, you can transfer over. Y-intercept, if your graph start from origin, then you can read directly. So graph starts. So if the graph starts from 0, 0, can read directly. If it doesn't start from 0, 0, then you must use y equal mx plus c. I hope you know how to use the equation. If not, go watch a video about it. I think Miss Ellie recorded one already. Okay, so use the y-intercept like this. And then finally, when they ask you to calculate some value, or for the last time, can we please stop using simultaneous equation? Please. There's no weird simultaneous equation in paper 3. If you see yourself drawing simultaneous equation, it's like you find chili jam in your egg fried rice. It is wrong. If I'm Uncle Roger and I mark your paper, I'll put down my leg. Okay? No weird simultaneous equation, no direct substitution, only taking values from your y-intercept and your gradient. So look at the graph that they ask you to draw. If you don't know how to do this, there are videos, please learn, okay? You should know this by now. It's the eve level of your 3. Okay, like. So we plot a graph of 1 over I and R. You see lah. If you cannot see, then you rewrite this one. 1 over I. This entire thing is my Y. Okay, and then R, you can rearrange so that R is here. This entire thing is my x-axis, right? Plus x over E. So this thing is gradient because y is equal to mx, okay? Plus C. This thing is your y-intercept. So if the question is asking you to find the values of E and X and include appropriate units, okay, what you can do is you will write 1 over E is equal to the gradient that you find, and you substitute the value of your gradient, and then you find your E. If I don't see this, you will lose a mark. Highly likely you will lose a mark because what are you doing? Nobody knows what you're doing. So please explain to the examiner whatever value you got for your gradient here, you are using this here because you know that 1 over E is gradient. Write this. All right. X over E is equal to y-intercept. So always start from this line. Then you substitute your values in. What is your E? You found E already, you put inside here, lor. Y-intercept you found on top, you put inside here, lor. Then you can find your X. Okay, and then make sure you know how to write your units. So it's either you infer from the experiment. Like for example, here is how I can like cheat a bit lah if I don't want to use my graph. Okay, so I go and look at what is E. I think E here stands for EMF, but you can always look at this to confirm. All right, so if I want to find the SI unit for E, since I plot 1 over I against R, my gradient unit, this is 1 over I. So this unit is ampere negative 1. So I will put ampere negative 1 here. And then this is ohm. So I'll put ohm here. So if I divide, I will get 1 over ampere ohm. Okay, so my gradient unit is actually ampere ohm. But you know V equal IR. So this is volt. You can write volt. You can even write ampere ohm. Okay, for X, X is y-intercept times E. So what is my y-intercept unit? My y-intercept unit is ampere negative 1. E is volt, right? So I can type volt. So this one can be volt over ampere. But volt over ampere is V over I, what? It's R. So this one is actually ohm. So this one can be volt over ampere or ohm. Okay? So you either follow the graph is okay, or you can actually write the actual SI unit if you know what it is. If you don't know, then follow the graph. If you follow the graph, it will be the second unit, a ohm or volt per ampere. If you know basic stuff like this, then you know it's V volt. So that's it for question 1. The only thing that matters is that we are talking about really standard stuff, and if you don't show any key parts of the working, you will lose mark. If you don't respect your data and give them equal treatment, you will lose mark. If you don't read the experiment properly or you don't know how to use the instrument, you will lose mark. Oh, okay. What about question 2? Hang on. I see the chat pinging. I will talk to the chat. Yeah. Okay, so there's a question from the chat. The broken line doesn't represent the number of battery, okay? Whenever you see a circuit diagram, it just means there are more battery, we lazy to draw. Broken line here means more battery, lazy to draw. You know TLDR? Too long didn't read. Too many batteries didn't draw. It's the TLDR version for circuit. Dotted line means, everything here is the same lah. Lazy to draw liao, dot, dot, dot. You know, like teachers, they say, you can do one lah. You just find gradient. You solve this equation. And dot, 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 then you get C. We assume you know how to fill in the blanks. We assume you know how to fill in the blanks between here. It is the same repetition, the TLDR version, okay? Next question. If the setting is 20 millivolt, then all the answers will be in millivolt. Yes. Okay, if you want to be very sure, please go to the playlist, either on stream or YouTube, and watch me use the multimeter. Because the best way for it to make sense is actually for you to you turn it yourself, but you don't have multimeter at home, correct? Too late to order from Lazada, although today is 5.5. Watch the playlist. Okay? Watch the playlist. If there is a decimal point, so generally when it comes to this kind of instruments, right? Let me go back to open up the instruments. Although I don't think we took a photo of it. But if I see this, you see this one is 20, right? And there's a decimal point here. This is 1.41 volt. And then when you put this one, the decimal point disappear. And then let's say you get like 11000. Takan is 1000 volt, right? That is just too big. It's just a tiny baby battery. Baby battery cannot give me 1000 volt. Sort meh? Crazy. Okay, so then it's only millivolt. Okay, same thing as this one. So if the knob is volt, everything here is volt. When you reach here, it will be millivolt. Always the best way to think about this is consider the label and consider your common sense. Or you have one battery, ma. There is no way on earth you will get anything more than one battery's voltage. Unless you have superpower, you increase the potential difference. Ooh. Ooh. Okay, next. I don't understand the 1.5 or 2.5 comment. Okay. Just read the question and look at the instruments given to you. If they give you 3 battery, you use 3 battery. If they give you 10 battery, you use 10 battery. If they give you 1 battery, you use 1 battery. Okay? Can? If you are not sure, you can just raise your hand. Hi, Jer. Do I use all battery? And then you see whether we answer you or not. Watch the video. Okay, we have a paper 3 unboxing video that we recorded 6 months ago. It's still relevant today, so go and watch. Okay, question 2. You're going to measure a bunch of stuff. I just would like to tell you that CIE is very sneaky one. They will sometimes include the unit and sometimes they don't include the unit. If they don't have unit here, whatever that you measure must have unit. Whatever that you calculate don't have unit, never mind. But when you measure, this card, you take your ruler to measure, you must put unit and everything here must be to the nearest mm. You use a meter rule, ma. Okay, this card is about A4 size one. Okay, so we hang a card like this. Okay, and then we adjust the position of the paper clip so that the height is horizontal. And then we measure the distance of the paper clip to the edge of the card. Then you estimate the percentage uncertainty in D. You are going to measure this distance using a meter rule. So there's no way you are going to like accurately know where to start measuring because this thing has a diameter, you know, the knob here where you put the paper clip. And this thing is probably going to, you know, shake a bit, rotate a bit. So I don't think your accuracy will be 0.1 cm. It's going to be maybe 0.2, 0.3. So like what I told you this morning, please increase your absolute uncertainty 2 to 3 times. Okay? And if you forget, we have another, again, pocket guide here. And then we already explained now why we uncertainty and how we uncertainty and why is it important to actually look at what you are doing. Okay, so there are a few, this one you can, this a lot of detail lah. So I'm not going to go into it. My whole point is when you are measuring this, please take 2 to 5 times the smallest reading because you cannot measure this thing accurately. It is very finicky. Okay. Next. Estimate the percentage uncertainty in D. So it's the same idea. Calculate all this, no problem. And we're going to repeat and cut the card. So okay, we cut the card, we repeat the experiment, and then we find K values. So here is where students struggle because you're going to write limitations and uncertainty. So here's what I can suggest you think about. Whenever you take out a ruler or a timer or anything to measure, you ask yourself, what am I assuming or estimating? If I am assuming or estimating something that I shouldn't, then this one should be here. Okay? So what I'm trying to say is, let's say you go and put let's say you want to measure this one. You don't know where to measure the head from. This part here. When you go measure the center, side. This one is like a nail. You don't know where it starts. Like confusion. So the diameter of the nail will affect the measurement of D because you are just roughly, whenever you have this, you know, the Asian way of cooking, you just throw only, you just roughly lah. So whenever you roughly in paper 2, you can complain about it. So I'll complain about the nails. Okay, what else can I complain about? I can say that the card is not stable. No, this card is probably going to move if, let's say, I push on it a bit, or maybe something some wind. Oh, I can talk about the wind. Okay, so whenever you measure something, I'm just going to jump right into the mark scheme to save us some time because I gotta go soon. So here, you can say difficult to accurately locate the center of the paper clip. Either the clip too large, clip not vertical, size of the clip not straight. Difficulty to attach because this card fall all the time. Difficulty to measure D. Why? Touching causes the card to move. Touching disturb the equilibrium. Ruler held by hand in mid-air, and because of this, it causes parallax error. Try to not just write parallax error, always include some description. You can also say the card bend easily, corners on card may not be a right angle. Okay, so how do we improve this? Improve the location of the clip. So you can use a narrower paper clip, or you measure the width of the clip and then you divide by 2. So you measure the width of the clip here. It's too big. You measure the width of the clip and then you divide by 2 and you include that into your measurement here. Hiya, so much work. Yeah, know what to do. You just write only ma. Okay. Then improve method of suspension. So instead of using a paper clip, you can put a pin, right? A pin is better. Okay. Or a hole with a needle. Okay. Then we can measure D properly by clamping the ruler or drawing the scale on the card. Okay. Or remove the paper clip and then measure it on the table. Use a more rigid material if it bends properly, or detailed use of a set square or a protractor. That means using a set square, ensure that the card is at right angles. So that means you have to tell me how you intend to use the set square or the protractor. Okay. A, limitation and improvement A can be written for all questions. This is the CIE bonus for you. 2 reading not enough to draw a valid conclusion. Take more readings and plot a suitable graph. We also have difficulty in judging the top, whether the card is horizontal or not. So what you can do is you can use a spirit level and you can clamp the ruler. Basically, you turn off aircon. I will write just turn off the aircon and close the window. Okay. So whenever there's a difficulty in doing something, always include why. Whenever you say, I want to improve a method, I need to explain what. So the whole idea about limitations and uncertainty is, if let's say for limitations, your sentence will always start with difficult to either measure something due to something, full stop, or difficult to ensure something due to something else. Ensure the card stays in place because it will slip from the paper clip, due to or because. So this is due to problem with instrument or method. Very hard to measure the paper clip lah, this lah, that lah, the paper clip blocking. This one difficult in setup. There could be some overlap between these two, but generally you think about this one. So during the setup process, is there any problem? During the measurement process, is there any problem? Okay, so one last thing before I run off would be the other question that the college got, which is this one. So we stick a ruler like that, and then we measure the height. Okay lah, I got uncertainty. I got complaint now. I got complaint. How can you know where is the highest point of the ruler? Difficult in determining the highest point of the bent ruler and measuring h. That's what I'll write. I'm going to put a wooden strip here like a ruler. And then what it will do is we'll push one side down and then it will oscillate. And then we determine the period of oscillation. And then we repeat 2 readings. How do we repeat 2 readings? Oh, you change the value of L. So this L also got problem 1 because you stick this using masking tape. It's probably going to fall out. So let's look at the limitations. And this is how you can study paper 3 tonight. You can play games with your friend also. Let's guess together. Nah, See, difficult to measure H because difficult in locating the highest point. I got 1 mark already. Difficult to measure L because L is hidden behind the tape. I got 2nd mark already. Oh, got oscillation. Oscillation confirm can write this one. Difficult to measure T, period of oscillation. Why? Because we cannot judge when the oscillation start, when the oscillation stop. Difficult to handle tape because of stickiness. This one. Difficult to hold ruler in bend position when sticking the tape. Okay. And also H changes when the strip is pulled on the top of the curved ruler. So when you put the strip, when you put the ruler, when you put, where's the question? Here. You put the ruler here, this thing will sink a bit one because this thing is like a soft plastic. So the H will change when the ruler is placed on top. Okay, how to improve? So push the ruler against a fixed bench when fixing the tape. Hold the ruler between the clamp blocks instead of using tape. So instead of using tape, right, we can actually just clamp the box like this. You have a box and then you G-clamp it to the table. You have another box. You G-clamp it to the table. And this two is fixed already. Then you just put the ruler inside. Okay? You have a block, you clamp it to a table. You have another block, you clamp it to a table. And then in between, you bend the plastic ruler. This is actually a piece of plastic ruler and you put inside. Then you can change the position of the block by adjusting the G-clamp. This is what they mean. Okay, measure H using a set square. Okay, so set square will allow you to decide the highest point because the highest point is parallel or almost parallel to the bench. That will be the easiest one. Okay, so whenever you cannot time something, always video record and view frame by frame. Video record with timer and view frame by frame. Or you could use a fiducial marker. This one is very standard. I've discussed in many examples before, oscillation. And finally, if you want to measure H, is there a problem? I'll measure H. 讲了. What else? Okay, that's all. No more. Measure H with strip in place or use a lower mass or use a stiffer ruler so that it doesn't compress under the weight of the wooden strip. Okay, and that's it for paper 3. So tonight, when you study with your friend or you study alone, I recommend you go through, if you need to, the playlist, okay? Hopefully it's linked in the description or linked somewhere that is easy for you to find. And if you have any questions, you can ping me. When I'm free, I reply lah. All right, so check out all these notes. You can find them in your class teams. Okay, if you cannot, again, you can ping me lah. I will reply to you maybe around 7. Okay, so all of this is recorded here. If you confusion between chemistry and physics or bio, just read. Okay, that's all. This one, the science lecturer prepare for you one because you always confuse. Why you always confuse? All right, so this will be fine where you normally find your classes lah. All right, so I don't know what is enthalpy change graph. I don't know what is all this. I just know the physics one. Hopefully you know the chemistry one. Okay, bio one I lucky don't know. Okay, so for physics we draw best fit line now. We are not connecting all points with ruler. No. Our best fit line cannot be a curve. It's only straight line. We very straight one. Okay, so just read through all this. You got any confusion, you can get in touch with me. I will see you in the labs if you're coming. I'm going to stop recording now.